So we are looking at special products of polynomials. There's a couple patterns that we're going to look at here in this particular section, but this is really very similar to what we saw in section 7.2 when we're multiplying polynomials. So the first pattern that you can see here is when we have the square of a binomial pattern. So notice we're looking at something like x plus 5 in parentheses, and that entire quantity is squared. What they're showing you is a pattern that you can use to help to remember that square of a binomial pattern. So what they're showing you here is you can just take the first term, square it, the second term, square it, and then take these two terms, multiply them, and double it to get that middle term. You also can just do this in the exact same way that we saw previously, where if we had x plus 5 squared, and that's the entire quantity squared, that's the same thing as doing x plus 5 times x plus 5. And then, depending on which technique you like, you can either use the distribution technique. X times x is x squared. X times 5 is 5x. X times 5 is 5x plus 25 to get x squared plus 10x plus 25, the same thing that we just saw there. You could also still use your box technique. If you're somebody who likes the box technique, you can do that. You have an x and a 5. I'm going to run out of room. An x and a 5. And draw your boxes and go get the same answer. What they're showing you here is that there is a pattern that exists, as I said. If we have something in the entire quantity is squared, we take our first term squared, we take our second term squared, we multiply the two parts together and double it to get the middle term. So I'm going to kind of just show you what that might look like here. If I take my a term and I square it, that would be 3x squared, quantity squared. If I take my second part and I square it, that's going to be 4 squared. And then my middle term is going to be 2 times 3x times 4. You end up getting here 3x squared is going to be 9x squared plus 24x plus 16. Do I think you need to do it that way? No, I don't think so. I think you can go about doing it in the way that we've been doing it. 3x plus 4 squared is the same thing as 3x plus 4 times 3x plus 4. Then we can go ahead and we can distribute. Use your FOIL technique or the box method if you want. 3x times 3x is 9x squared. You'll notice we're going to get the same thing, plus 12x. 4 times 3x here is going to be plus 12x. And then 4 times 4 is going to be plus 16. Combine in the middle, 9x squared plus 24x plus 16. So if you're somebody who's good at memorizing patterns and you think you can do it that way, go for it. If not, just use your same FOIL technique or your box method that we saw in the past. So if you want to use the box method, you're somebody who likes that. I'm going to have 5x and a negative 2y. And then remember, this is really 5x times or minus 2y times 5x minus 2y. So then I'll have another 5x and another negative 2y. And then we'll go through the same thing. Okay, so 5x times 5x is 25x squared. 5x times negative 2y is going to be negative 10xy. Multiply the numbers, keep the x and the y. Same thing here, negative 10xy. And then negative 2y times negative 2y is going to be a positive 4y squared. We do have some like terms here. They're right here. Just because there's two variables, maybe slightly more challenging, but not overly different. Let's put it all together. 25x squared minus 20xy plus 4y squared. And again, I've just shown the box technique here, but you can certainly use your foiling technique if you're somebody who's more comfortable with using distribution. We'll look at the try these in class. We're going to look at another pattern here, which is called the difference of squares, or the sum and difference pattern. Okay. So if we look at this particular part in here, notice that we're dropping our middle term in here. That's when we have x plus 3 times x minus 3. And again, you can just use your FOIL technique or your box method to get that answer. You don't necessarily need to memorize the pattern that's shown here. But if you're somebody who wants to, go for it. So I'm just going to use that FOIL technique to get my answer here. And you'll notice what's going to happen is your middle term is going to cancel on all these when you have opposite signs. So t times t is t squared. T times -5 is -5t. 5 times t is positive 5t. And then 5 times -5 is a -25. So notice here, on these particular problems, your middle terms are going to cancel out. That -5t plus that positive 5t are just going to cancel out. And what are we going to be left with here? We're just going to be left with t squared minus 25 as our answer. If we look at our next problem, again, I'm going to use the FOIL technique. I like that. 3x times 3x. 3 times 3 is 9. X times x is x squared. 3x times -y is going to be -3xy. Y times 3x is positive y 3x, or if we change the order around, positive 3xy. And then y times -y is going to be -y squared. Once again here, our middle term right in here, those are going to cancel out and go totally away. So what are we left with here? We're just left with 9x squared minus y squared. We'll take a look at this example in class, as well as the your turn. That's all for today. Again, it's just kind of going into some special cases with some of the multiplying of polynomials. If you want to remember the patterns, go for it. If you don't want to remember the patterns, you don't need to. Just use your same box method or distribution technique that you've been using to multiply polynomials. See you in class.